Wonderful. Okay, I'll get started. So hi everyone. Today I'm going to talk to you about the OWASP Top 10 for JavaScript developers. Let's see if I can find my mouse. I'll just use this then. Okay. So just a little bit about myself. I'm a senior security consultant at Synopsys. It used to be with Cigital, but we got acquired by Synopsys, and I've been there for about 4 years. I'm also one of the Angular San Francisco organizers, where we do monthly meetups around JavaScript, TypeScript, and specifically Angular. And I also did a degree in ethical hacking, where I founded the Leeds Ethical Hacking Society. And the reason why I'm talking to you today is because I'm a JavaScript enthusiast. I love JavaScript. I'm sure a few people in the room also agree with that, but a lot of people tend to hate JavaScript. But I am not one of those people. So what is the OWASP Top 10? Most of you know what the OWASP Top 10 is, but the OWASP Top 10 is a powerful awareness document for web application security. And the OWASP Top 10 represents a broad consensus about what most critical web application flaws are and that exist in web applications. So the reason why there's multiple colors is because the items in green are data-driven, the items in orange are community-chosen, and the items in red are either substantially new or changed since the OWASP 2013 version. So what I intend to do today is try and cover as much as I can in 30 minutes on the OWASP Top 10 and how it relates to JavaScript. I can't cover it all, but there is an extended slide deck online after this presentation with lots more demos that you can go through at your own leisure. So let's talk about A1 injection first, the dangers of mixing data and code. So the main issue that is caused through injection is when we mix data and code, where user input is treated part of the code context itself. There are many types of injection attacks. So there's like SQL injection, NoSQL injection, log injection, and also command injection. But the list goes on, and I don't want to bore you to death because most of you know the different kind of injection attacks that exist in common applications. But let's take a look at two that you might see when you're looking at JavaScript or Node applications in general. So the first thing that I want to talk about is NoSQL injection. And the official Mongo documentation that it's not vulnerable to the traditional SQL injection attacks because objects are represented in BSON query, or BSON queries are represented in BSON objects. And whilst it might not be vulnerable to traditional SQL injection, it's still vulnerable to injection attacks if user input is directly included in a collection method. So one example of this might be that you have a find one method, collection method, and you're trying to retrieve a user from the database. And this can be abused if you can include a Mongo query selector, such as $NE, which is short for not equals to, if you can include that, or $GT to something that's greater than. You can use this to abuse and log into the application. So let's just take a quick look at a MongoDB example. So we have this find one collection, or this collection with a find one query. And this is coming from user input because we have the request.query.user and passwords. But the injection here would be if you included a $NE on the password field, because what this actually would do is convert the query output to basically say that the password is not equal to an empty string. So you want to make sure that you're trying to prevent this in general. And of course, under the hood, this would check to see if it's an empty string, and 99% of the time, the password isn't going to be an empty string. It's going to be either a hash password or clear text password, hopefully not. So let's just take a look at how that might actually work in practice. So we have a simple login post route where we have this authenticate function. This authenticate function takes in the body, and it takes in the user and the password, so from the body parameter. And then it takes it into the authentication. And it goes to connect to the MongoDB instance, so this time it's localhost. And then we have that simple collection. Now, obviously, this would be vulnerable for various different collections, but in this case, we're going to talk about find one. So this will just try and find one user, make sure it matches, and obviously, under the hood, this may do some other things, but for all intents and purposes, this is a very simple application. So obviously this can be bypassed, which I mentioned, with the username of admin. This could also just be greater than, and then the password would be greater than, and it would return back the entire collection. But as we can see here, we have the find one with user and password. So if we include that password with $GT and we go to the application, we try and log in with a fake password first. Obviously, you should never do this in clear text, but anyway. So as we saw, if we intercept that request and send that again to the server, and we do fake password again, once we capture that request, we can now delete the fake password and just include the $GT. So this will allow us to, because the password is greater than whatever was supplied, which is an empty string, this is going to allow us to log into the application. So the simplest way to prevent Mongo injection is to ensure, obviously, the safest way is to basically ensure what you're expecting is either of a part string, so it's directly used in the global string object directly, or you can perform custom data validation. So one popular library from Happy is Joy, and you can define custom input validation on particular either user inputs or on a scheme. So you can do this by defining with, like, it must be a string, it must be required, it must be of a type, between 30 and 50 characters. Whatever you want to do, you can do that with Joy. So even SQL injection exists in Node applications today. We cannot escape that relational databases are here to stay. They're going to be around for a long time. So as you can see, Drake is not very happy when we dynamically include the object user through string concatenation and as part of a query string. But Drake is very happy when we're using parameterized queries to ensure user input is safe. So let's get back to some serious content. That's enough Drake. When we think about input prevention, we want to make sure that we're doing first input validation, and we want to try and do data normalization so that input validation is actually sane and it can be properly validated. But then we may also want to consider, when we're dealing with XML files or various different files, performing something like output encoding, because as Philippe Diric, if anyone went to his presentation, input validation cannot be used as a standalone protection. It has to be conjoined with something else, such as output encoding. And then when we're working with databases, you might want to consider parameterized queries or safe APIs, such as stored procedures, because stored procedures don't always save you from SQL injection, but if you're doing it correctly, you generally are. Okay, so now we're going to move on to broken authentication. So one of my colleagues, Amanveer Sangha, reviewed an Internet of Things application in China while he was on site, and it was built with Node, and it was using the Express framework. And they wanted to preserve memory, space on the device by not using custom middleware or authentication like Passport. They wanted to write their own because it would be cheaper. So what you can see here, and obviously this is vulnerable to Node, but it also could be vulnerable to the client side too, but it would be less impactful. But what we have here is a simple object called sessions, and then we have this must be authenticated middleware, which takes in the request, response, and next. And then we take a look at the cookie, and that cookie is basically assigned to the token, and then we check to see if that session token exists in the session object. And if it does exist, then we'll go to the next. Otherwise, it will say not authorized. Now, this looks like it could be okay, but if anyone's looked at JavaScript for a long time or enough, they're going to take a look at this comparison table and see some weird, wonky things. So let's just say that the session object contained like the authentication session, and it was checking against that value. But if you had an input validation string, which was an invalid string against that session object, it's going to return false, which makes sense because if it's not there, it shouldn't return true. The same for if all that was supplied was an empty cookie. That would obviously return false as well. But then we get to some weird, interesting concepts where if you have the session which is constructor, it's going to return to true. And the same for has own property, which is going to return to true. Now, the interesting thing here is because when you create a JavaScript object, it essentially descends the base object. So by default, you have these values such as __proto, which can be used for various dangerous things like prototype pollution, which I don't cover today, but I'm sure someone in the audience probably will. looking at you. There's also a constructor and has own property and is prototype of. So what we saw before is basically saying the same thing as, does the sessions constructor equal to sessions.constructor? And that, of course, is going to be true. So the exploit here would be fairly trivial. All we would do is basically do a curl request and include a cookie, which says token equals to constructor. Or alternatively, you could just go into the browser and open the developer tools, add in the document.cookie and assign it to the token constructor. So let's take a look at another example, if I can. So I've lost the mouse. Okay. Okay. No. Yep. Okay. So let's just replay this. Is it replaying? Nope. Let me just kill it and try again. Okay. So play. Okay. So let's just say we have the simple express application. And as you can see, we're using the cookie parser to be able to retrieve the cookie. We have that sessions object, which is empty, and we have that must be authenticated middleware. So what we're happening now is obviously we take the request cookies, we assign that to the token, which then is obviously checked to see if it exists, and if the session token contains that value. And if it does, go next, otherwise say not authorized. And then obviously we're appending that as middleware, so before it even makes it to the get route, it's going to check that. And as you can see, when we refresh the page, it says not authenticated. But all we're going to do is go into the developer console, define the document.cookie, assign that token constructor, and then refresh the page. And as you can see now, it says we're authenticated. And then I zoom in for dramatic effect. So obviously this is quite bad, and this definitely shouldn't have happened. But it's an unfortunate consequence. So how do we correctly check this? And whilst I would never recommend you write your own authentication, unfortunately sometimes it's a necessity. So I would highly recommend looking into using the crypto library, which has timing safe equal, because when you're doing things like sensitive password comparisons and various other things, if you have a double equals or triple equals, this is vulnerable to timing attacks. So you should never do that anyway. The next thing is, of course, it performs a safe comparison. So it's not going to check the base object. It's only going to check the input string. And then you can also just do this very hackily. It's not hacking, actually. It's a relatively okay solution. But you can use the object.hasOwnProperty, or if you're using maps, the S6 maps, you can use .has. Oh, I repeated the thing. Anyway, that was meant to be .has. So basically, these do not check the base property. So these are safe to use in this context. Okay, so now let's move on to XXE. So we all know that XML external entities, XXE injection, is very common in pretty much all languages that we see. And Node in this context is no different. If we want a quick recap, everyone knows what XML injection is, but we have XML. The XML standard includes the idea of external general parsed entities, an external entity. And then during the parsing process, the XML document, the parser will expand these links and include the content of the URI in the returned document. And a common attack is basically to include like a DTD, so a document type definition, where you include some entities. You can do rather malicious things like try and do denial of service through billion laughs attack. You can do trying to access internal resources and various other means like trying to do port scanning on your internal host. And Node is no different. It has a lot of XML parsing libraries. I had an argument, or someone told me that no one uses Node for XML, but I mean, I'd beg to differ when there's 48,000 weekly downloads and 47,000 weekly downloads. So Node expat is actually in particularly vulnerable by design. If user input is being entered into this parse function, it's actually vulnerable by design, and you can't do anything about it. You would have to do extra layers of security on top of that to make it safe. There's also libxml.js, and that libxml.js is vulnerable if no ent is set to true, and this means no entities, which doesn't really make sense from a configuration perspective. Maybe there should be entities set to true rather than no entities. But I think that's a generic Java or previous standard that was set in the old implementations, because this is like a port of other implementation libraries. So let's just take a look at the DVNA, which is Damn Vulnerable Node Application. This has been created years ago to demonstrate some particular issues. So as you can see here, we have the request.files, and basically it's taking in some data, and obviously the MIME type is set to text XML, and it's going into the parse XML string. That would be safe by default, but unfortunately, we have this no-ent set to true, which means you would be able to achieve XML injection in this context. You could retrieve local instances from the files, you could do denial of service, you could attack the web server, whatever you wanted, because the source here is obviously the request.files going into parse XML, and then the misconfiguration and the sync here is the no-ent to true. So how would you try and prevent this in Node in general? You may want to consider just using a library that doesn't pass DTDs. So there's Sax.js, and Sax.js doesn't even process entities. You can configure it in a way where you can do that, but by default, it's technically a safe implementation. And when you want to use safe libraries, definitely consider using libxml.js over Node.expat, because it is safe by default, but you have to make that configuration change to make it vulnerable. And then if there are contexts where you need like the ampersand or greater than converted into actual attributes, you may want to consider using lodash or underscore or he to basically do unescape functions on, technically on HTML, but in this context, XML. And of course, if you can't really approach those things, you want to make sure you're doing strict input validation and output encoding before actually passing the data. Okay, so let's talk about broken access control for a second. So we now live in a world where most of the routing is done on the client side, and the client and server trust boundaries have started to meld together. We have many client-side frameworks and libraries now that offer some kind of authorization, but this intended purpose from the client side is purely only for aesthetics. It's not meant to be used for security. But the sad truth is this is often neglected when we look at many applications now from either a source code review or from a penetration test. We tend to see that these server and client-side boundaries have melded together, and all they're doing is doing client-side controls to protect themselves against elevated privilege. So when you are working with Node.js, there are some things you can consider for the server side. So first, you may want to use like Node Casbin for authorization. So Node Casbin allows you to write access control lists. It allows you to write role-based access controls and attribute-based access control. You may want to move this over to a framework to do all the hard and heavy lifting for you. So Sales.js allows you to easily write policies that might be good to make sure that a person is of a type admin. It's very easy to do this inside Sales.js. And then finally, you may want to write some custom middleware. So custom middleware is very important when you're working with things like JWT or JSON Web Tokens or JOT, however you want to call it. And you can do this at various different levels. You can do this at the actual route level. So as you can see in this example, we're doing like auth requires role admin. You would obviously verify the JWT, then check against that. Or you could do it if you wanted to make sure someone was authenticated first, you may do it at the pre-route level, so before it even reaches these routes, or you may want to do some things afterwards at the after route. It's entirely up to you how you want to deploy that, but these are just some potential solutions you might be able to deploy in your organization. So just to give a quick Angular example, and I'd highly recommend taking a look at the second link here. But Angular has some built-in client-side validation checks which can be used to load resources or show and hide state. You have things like can activate child, can deactivate, can load, resolve, and so on. And obviously, this is nice from a user experience and what should be shown to a user, but obviously these things can easily be trivially bypassed. Maybe if they're doing it on the server and only then rendering the data, it might be okay. But most of the time, single-page applications throw everything to the client, and then depending on the JSON responses they receive, what data they have, that is how it's represented on the client side. But the one interesting thing about Angular as well, I'm not picking on Angular because it's bad, it's actually a super great framework. But you can basically use its super powerful ng probe, and that's what the second argument, the second blog post talks about, is how you can use ng probe to probe the client side. And you can do this basically to take a look at its components. And if they had like an authentication component or an admin component, you could then basically start to manipulate the changes in that aspect. So now I'm moving on to security misconfiguration. So Node.js and most of the frameworks that are built on top of Node.js return verbose error messages, as you can see from the top example, if the default value is set. So if you tend to see like, a file is not found or a certain error came back, you would want to make sure that this is set properly, and then you can do this by defining the production mode with the node environment. You can also actually set this as a middleware. So you can kind of consider this at all routes, you want to make sure this middleware is set. So before anything runs, it's set to production with the node environment. So that technically would save you from if your actual server implementation changes, or it gets deployed to a new server and the node environment changes. So you can do this at the middleware layer. And of course, we all know about the dangers of running as root, but any Linux application running with sudo has a greater chance of modifying the underlying operating system. If they have like a command injection, for example, they could obviously just do rtfm/. But there's some things that you may want to consider. So for example, if you may want to go through the default run scripts to make sure they're not running with sudo. That's the first thing that you can do. And the second thing you can do is sudo is required after the port is bound. You can essentially then call process and set the GID and UID. So these are some things you can consider in Node.js. So let's move on to my most arguably strongest topic, and I have a lot of things to say about cross-site scripting. Okay, so XSS is super easy to introduce, and I think Koto and Mike's talked about the same things that I'm about to talk about now. But as we all know, DOM XSS generally occurs when injection syncs in the DOM or other browser APIs are called with user-controlled input. So as you can see here, we have a source such as location.hash, and then it's being assigned to the inner HTML, which says welcome username, or it's being appended in this case. And of course, the script execution context here would be just to include the username, and that should be a hash, not a parameter. But obviously, if you had a hash here, this would allow for the execution. So, and DOM XSS in today's ecosystem is super difficult to find. You'll notice that most static code analysis tools cannot identify DOM XSS. It's pretty paramount that it's so difficult, and obviously when you're defining variables in a way, if you take a look at these HackerOne reports and you take a look at the code, you're going to go, where is the DOM XSS? But it is actually quite difficult to identify. And browsers actually tend to parse and render HTML differently. So the DOM specification for each browser, while there are standards, they're not always conforming to those standards, and they implement things a little differently. So there's a good explanation from Live Overflow where he goes into a lot of detail about the Google XSS. But then he also goes into detail about why is this thing rendering this way on Firefox, or why is this way rendering on Chrome. And there's some wonderful examples on shazza.co.uk, which is basically a fuzzing website for browsers. And Insert Script, known as Alex, and also Gareth Hayes, have some wonderful examples on there about how you can get quirks, like there was like things trying to remove a greater than character to bring an entire string together in various different contexts. And of course, the dangers of the DOM as well, or browsers in general, is that there's so many execution contexts. There's wonderful resources like html5sec.org that you can take those payloads and basically use them inside your security unit tests. 5 minutes, okay. And of course, there's also character sets. So browsers come with various different character sets like UTF-8, UTF-7, and then there's like Japanese ones as well. And Internet Explorer 6 was crazy and just threw a ton of character sets in there at some point. So there's tons of different ways to basically get JavaScript execution, even when it doesn't look like JavaScript execution. And then you also have script gadgets, where it's basically taking HTML injection and being processed in a way where it's executed by JavaScript. So I'd highly recommend taking a look at all these resources, and then you'll kind of get to the point why you understand things are so difficult. So I have 5 minutes and 20 slides. Let's do it. So frameworks like Angular, React, and Vue definitely reduce the attack surface, but I'm not going to go through all of these, but essentially there are abundance of ways that you can introduce XSS by basically using frameworks in a way which are either being abused in various different aspects. So the first example would be to combine templating engines with third-party libraries and frameworks. So in AngularJS, if you included jQuery.text, which in general websites, that's actually a safe way to insert HTML. But with jQuery.text, Angular would actually render curly braces as part of the Angular expressions. So you would technically get XSS. You could obviously do all the others as well. One interesting one is element ref, because it allows you to access the DOM, so you get inner HTML. So I'm not going to click that. So basically, I'm going to ignore this video. You can watch it online through the video. Oh no, now it's playing. Okay, so as you can see here, we get remote code execution, and it's quite strange why. And this is because one line of code in the Signal application basically was using dangerously set in HTML. And this allowed you to essentially get various different execution contexts on the client side, or sorry, in the mobile applications, it was XSS. On Electron, it was remote code execution. So the general prevention techniques is quite critical here, and there's various different ways to achieve this. So you can use templating engines such as Mustache or Pog or EJS, and they do HTML contextual encoding. You can use Angular, React, or Vue to ensure that you're making sure that they're using their sanitization functions by design. And of course, there's secure filters. You want to make sure that you're doing DOM purify or doing client-side sanitization, because whilst it's good on the server, once you can render it in the browser, you can make a better, safe assumption that it is secure or it is sanitized properly. And of course, if you can use inner text or encode URI in the correct context, that is quite important. So I'm going to skip this next topic very quickly, but you should definitely look at defense in depth strategies. So you want to try and deploy CSP and take a look. Obviously, Koto and Mike just talked about trusted types, but I would highly recommend looking at these as extra layers of security on top of your applications. Okay, so 2 minutes left, and this is the most important part, everyone. So I'm going to go over time. Sorry. So this is the most important thing when it comes to, I guess, the Node ecosystem, and it's using components with known vulnerabilities. So it's very important to carefully audit third-party code. And obviously doing source code review is very critical in this aspect. But if you take a look at an NPM package list or any kind of package.json, you're going to see 1,000 of different kind of packages in there. And it's not going to be feasible to do source code review. But if you do find an issue in an NPM package, you can now use the new GitHub feature where you can directly report that issue to the project itself in a safe way. And of course, if you want to implement auditing tools in your CI/CD pipeline, you can use npm audit, yarn audit, audit.js, retire.js, and snick test. So you can use these in different contexts. You would use snick if you're using open source Node. You could use retire.js if you're looking at client-side JavaScript. You could use Bower for client-side package manager, Yarn with Yarn audit fix, which basically wraps over npm, and then also npm audit fix. So these are some simple examples, and what you see here is that obviously things like Next.js. Next.js is super important in the React world, but in 2 cases it was vulnerable to arbitrary read through directory traversal. It was also vulnerable to XXS, which obviously is quite bad because React adds a lot of properties. But if you build on top of that, you essentially are seeing a lot of problematic areas. So it's super important to do dependency checking on Node modules. So I saw someone was taking a screenshot, so feel free to finish that. Okay. So mitigation techniques. So this is probably the most important part that you might want to consider, and this is my last slide actually. So you want to make sure that you track outdated libraries and components through using SNCC or Retire.js or Yarn or Bower and so on. And you want to try and maintain a technology list, asset registry list, or in some way. But there was an interesting talk from LocoMocoSec that basically talks about code provenance and application security in applications. And what they tend to do is only do a subset of those dependencies, because if you go too far down the chain, there's less likely of a code sync actually happening from user input. But then you can build a technology list through things like the CLIs, so you can use it for NPM, there's ls, for Yarn, there's Yarn ls and Yarn y. And then, of course, there's Bower list as well. And one thing that I also might want to recommend for you to do, but it's obviously up to your interpretation, is basically pin your dependency versions where possible. Because there was obviously an interesting scenario with Event Stream, and Event Stream obviously was affected a lot of organizations. But if you can pin your dependencies to something that you once knew was safe, and then include that in the package when other developers install it by using npm shrink wrap or yarn lock, they're going to use this exact same dependency version that you were using, and therefore it may actually save them for being compromised. So that was everything that I had. The online version is at the bottom. There's the 30-minute version and the hour version with multiple demos there, so feel free to go ahead and take a look at it. If you have any questions, I'll be around. So thank you.